Okay, this is your quadratic forms review for your test tomorrow. The very first question, three-part question, says list the quadratic form. Well, first you have to know what those three forms are. We learned that we had factored form, and we can go between it and standard form. And we can go between it and vertex form, with standard form being our go-between in the middle. So you have to know those three forms, and then you also have to know which is which. This very first one is standard form. It's where we have ax squared plus bx plus just a constant c. So this is our standard form. Our second one, this is our factored form because it's broken up into its individual binomial pieces. Our very last one, that's our newest one. It's our vertex form. It's where we have this one quantity squared, x minus 1 quantity squared, with just a constant out back. Now, that handles the first part of the question. The second part for each of them is we want to name the critical point or points given by each. Each of these different quadratic forms provides a specific piece of information that is unique to it. Okay? The oldest one that we've been working with is standard form, and it's also one of the oldest pieces of information when it comes to graphing things. It's all the way back to when you learned y equals mx plus b. And it's that y-intercept, okay? Standard form gives us the y-intercept. More specifically, it's still this number out back, written as a point, 0, 3. Remember, our y-intercepts always have an x value of 0 and then a separate y value. B is factored form, and factored form tells us the zeros or the x-intercepts, okay? Same exact thing there. Use those interchangeably. For those zeros, though, it's a little bit more work than it was on the y-intercept. The zeros, we need these numbers, but because they're in parentheses, we have to flip their sign on the way out. And they're x values this time. So -1, 0 and 2, 0. Okay? Most of our parabolas we've looked at have 2 zeros. Now, there are other times that it has only 1 0 or no zeros or imaginary zeros, but most of the ones we've looked at have had 2 zeros. Okay? Part C, we were in vertex form, and that's right there in the name. This will tell us the vertex, the min or the max. Now, specifically, I did not ask whether it was a min or a max here. You should have been able to tell me this, though, specifically if you could answer the next problem. This is a positive number out front, which means this opens up, which means our vertex is actually a minimum, okay? And to find out what that vertex is, we need a little bit of both of the last pieces. To find the x value, it comes from right here, but we want to flip the sign, meaning it's +1. The y value comes off the very end, much like our y-intercept did, but we're going to keep that sign, okay? So just like we kept the sign on our y-intercept, we keep the sign on our y value. Just like we flipped the sign for our x-intercepts, we flip the sign for our x value. It matches up very well. Okay? It takes a little bit from each. Number 2, determine the characteristics indicated. Parabola opens which way? Well, that's determined by the sign of A. Okay? If the sign of A is negative, like it is in this problem, our parabola opens down. And just as a reminder, this isn't what it asked, but as a reminder, opens down looks like this, which actually means it has a maximum, interestingly enough. It's a little bit backwards. However, what it asks for next are the x-intercepts. Well, for the x-intercepts, we have to take these values and we have to flip their signs, meaning we have -2, 0, and this would be a +4, 0. These would be our 2 x-intercepts. So if you forgot what came out of factored form, you could just look at the next problem. Okay? For our second equation, parabola opens. Well, it just takes the sign of our A value, which in this case is positive, meaning it opens up. The vertex, again, we flip one of them, and then we keep the sign of the other one. So we flip in the parentheses, and we keep outside of the parentheses, okay? Number 3, write the function in factored form, determine the x-intercept. And that's good because that's what factored form tells us. But this is all the way back to last test. This, in fact, is not really much new information except for we're working more with these intercepts now. Going to factored form just means we have to factor it, which means we have to use our box method, okay? We do ax squared, ax squared times our constant c, which gives us 8x squared. We need factors of that add together to be 6x, okay? So it's got to multiply to be 8x squared, but add to be 6x. I'm thinking that's probably 2x and 4x, okay? Multiplies to be 8x squared, but also adds to be 6x. So now I'm ready to put all this in my box. Our top left corner is always occupied by our first term, x squared. Our bottom right number is always occupied by our constant term, 8. And then we break up this middle term into 2x and 4x. 2x, 4x. Notice if we were to add all this back together, we'd be back to the original problem, okay? So now we're doing GCF. All I can pull out here is an x, and a 2, an x, and a 4. Again, you could have shortcut it from right here if you remember that shortcut, because this is a leading 1. This is an x plus 2 and an x plus 4, okay? If you don't like that shortcut, we learned that you do just fine without it. So when I go to write my factored form, I have x plus 2 as one of my binomials, times x plus 4 is my other. And this gives us the zeros of negative 2 comma 0 and negative 4 comma 0. Again, notice how the signs flipped, okay? I keep calling them zeros. They're also x-intercepts. Use those interchangeably. For number 4, we're going the opposite direction. And this is math you've known for a long time, okay? You have 2 ways to do this. First, you can distribute the negative 2 into this first binomial because that's just multiplication, okay? That works perfectly fine because then you'd have, again, 2 binomials and you multiply those together. For some reason, though, most of you that I've talked to about this or most of the classes we've worked at this end, most of your general instincts, and I don't know if it's because we just got done with factoring or what, but most of your quick instincts are to multiply these binomials together, and that's fine too. We're going to leave that negative 2 out front. This would be x squared plus 2x minus 3x minus 6, okay? We're going to combine some like terms. We have negative 2 on the outside, x squared. Here's our like terms, so we get negative x, and then minus 6 stayed the same. Now we're on to our very last step of getting in standard form. We've got to take that 2 and distribute it. It's the only multiplication we have left, okay? I'm going to write our final answer over here to the side just because I'm a little bit out of room. Negative 2 times x squared is negative 2x squared. Negative 2 times negative x is positive 2x. Negative 2 times negative 6 is positive 12. That's standard form, guys. Now, there is some argument to be made over, oh, standard form, you can't have a negative in front. Standard form, you'd rather have it with that 2 factored out. No, just leave it right like that. That's fine. The best argument would be a negative being out front, but I'm okay with that. Remember, that was old standard form that we didn't like. Okay? This standard form, this is fine. This is ax squared plus bx plus c.